Hi, welcome to my row reduction video. So there are three row operations that we need to learn, and then there's a strategy to row reduction that everybody learns. So yes, you have to learn how to do it by hand, but MATLAB can speed up the process, so you can practice a lot more problems. And yes, there is this command called RREF that will give us full row reduced echelon form. However, we can do the row operation step by step, and that's what I'm going to show you. So we are trying to get a pivot in the top left. We have to have a pivot in the top left corner. All right. And -2 would be fine. We could work with it. But notice that I have a 1 right below it. And 1s are great for pivots. They save a lot of work later. So what I want to do is I want to swap row 1 and row 2. That's my plan here. So how do I accomplish that? And first, let me say that I'm going to do this on purpose, right? So capital A, that's usually how we refer to matrices. So I usually like to have that. Lowercase a is easier to type, and I'm going to be doing a lot of typing of that lowercase a. Also, this will preserve a clean copy, right? So I am never going to overwrite capital A. And if these steps mess up down here, I can always come back here and get the sequence of steps corrected. So that's a feature. Now I want to do my row swap. And so this is interesting. I want to swap rows 1 and 2. And so let me type this in. I'll explain what is actually happening in just a moment. And you'll notice this has accomplished what we wanted it to. So what does the code mean? Okay. So when I type matrix A and then I have, right, the row index and then the column index, that's inside parentheses. So that's what this whole thing means. And when I put that 1, 2 in there, that's saying, hey, I want you to look, it's specifying the rows. I want you to look at row 1 and row 2. And do what? Well, this says, hey, swap them, right? Whatever was in row 2 now goes into row 1 and vice versa. Okay? So the column call right there is this, is this colon. Okay, and what does that mean? It says just do it along all the columns, right? So once you figure out that row 1, we're going to take row 1 across all the columns. That's what the colon says. Take them all. Okay, so that's why it works. And I just want to mention, I'm going to come back to this in a second, but I just want to mention that you can do multiple row swaps. For example, I could say, well, 1, 2, 3 equals 2, 1, 3. Let's take a look at that and see what happens. And you can see that, right, the old row 2 has gone to the new row 1. So here we have old row 2, and it's in new row 1. And then here, what used to be in row 1 is going to now be in row. Oh wait, I didn't swap the third one. That's funny. This is a mistake. Sorry, but I can try it. Let's see. So let's do something that's not. See, I only reversed the 1 and the 2. I didn't. This is the same as before. So let me do something like 2, 3, 1. Maybe, yeah, that'll swap all 3 rows. And when I run that, again, it works the same way. Sorry about that. Right, that the all right, so the second row from here becomes the first row down here, right? That's what the mapping is. And the third row down here becomes the second row here. Okay, so I'm gonna get rid of this. All right, and now we're back to where we were. So we did this row swap. We swapped rows 1 and 2. Okay, well, after we get a pivot in the top row, oh, here's a pro tip. This is looking a little small, so I can use hang on, sorry. I can use Control Scroll to make it a little bigger, and I think that'll help everybody involved. And also remember, I can always go to undock. So let me try that. If I undock this and still stay within the recording rectangle, I'll just have a little more room here to show you guys what's going on. Okay, and so now I want to say that I'm good. I've got my pivot here. So after I get a pivot, I need to get zeros below it. Okay, so I want to get a 0 instead of that -2. Okay, well now we're going to talk about another row operation. So the row operation we can use, we have swap any row. We can multiply through any row by a non-zero constant. So if I wanted to, I could multiply through the second row by, say, -1/2 and get a 1 there. I don't want a 1 there, I want a 0, but I can multiply through. That's the second one. And then the third one is the one we're going to use. This is the one we use all the time. I can replace any row I want to with the sum of that row and a scalar multiple of another row. Okay, so it's a whole lot easier to understand when you see it written down. So let me jump in here and try it. So I want to say this. I want to say that row 2 in A, right, is going to be equal to row 2 in A, right? It's going to be the sum of itself, right? The sum of itself and a non-zero multiple of another row. So I'm going to go plus 2 times the first row, I think. Let me get that typed in. Right? Why? Because if I take 2 times this one and add it to this -2, I'll get 0, and I'll have a 0 here. And then I'll have 2 times this plus this will give me 6, and then 2 times 0, and a 0 will be 0, so this will still stay -1. Let's see if I got that right. Exactly, right? So now I have a pivot, and I have all ones below it, and I move down and to the right to find my next pivot. Okay, so my next pivot is 6. Let's go ahead and get my cursor back, get a little room here so we can see what's going on, get rid of those red dots, and so now what? Well, now I want to get a 0 where that 5 is. So let's think about how that will happen. I need to take row 3 equals row 3. Sorry, row 3 plus some non-zero multiple. And you're like, what are we going to do? Well, the problem is that I need to multiply this by -5/6. If I take 6 times -5/6, I'll get -5, and then I can add it. So let me try that. So I want to do minus, and I'm going to do it this way. I'm going to do 5 times row 2 divided by 6 and see if that works. Okay, it has. Now, notice a couple of things. So this is calling for row 2 and then every entry, right? This is calling for row 2 every entry. This is calling for row 1. So this is basically how I'm saying row 1. This is how I'm saying row 2, okay? Next thing, notice that this is just switched. So as long as it can keep the integers, it will. But as soon as it has to go to real numbers, to floats, to doubles, or that was what they're called, it's a different type of number, then all the numbers start going that way. This is still an integer, but the whole matrix, every number in the matrix gets converted over to a double. I guess the zeros aren't double, but maybe they are. I don't know. They don't look bad, though. The others do. So it does get a little busy, all right? And now I have what's called row-reduced form. This is REF, not RREF. So REF has what properties? Well, this has been in your reading. The properties of a row echelon form are that I have my pivots going down and to the right, right? Every pivot is in the next row and to the right of the pivot above it. Every pivot has zeros below it, right? And if there are any rows of zeros, they have to go at the bottom. Any row that's all zero has to go at the bottom. And then we're in row echelon form. Okay, now to get into our REF, we have to get zeros above the pivots, and we go backwards, right? So when we're starting out, we go down the main diagonal, and sometimes it's not just down the main diagonal, we have to step over and down. But that's the pattern. We start in the top left and go to the bottom right. But to get the zeros above the pivots, it works if we start at the bottom right and go back to the top left. So let me show you. So I want to get a 1 above there. By the way, here let's use our third row operation, which is multiply by a scalar. So I want A3 to be equal to 6 times A3, right? Because I have a 1/6 here and a 0 here and a 0 here, so nothing's going to change when I multiply the 6 times this 0 or the 6 times this 0, but it's going to turn this into a 1. Okay? And I probably should have multiplied by -6. Do you see that? And then end up with a +1. Okay? So, and by the way, that's the great thing about this. If I make a mistake anywhere, I can just fix it here, and then every time it's running the whole section. So when I hit Control Enter, when I hit Run, every single one of these things refreshes. And so if I make a little mistake here, you know, this is what I had done, I'd gotten this thing wrong, and I'm like, you know what? I don't have to do another step down here to fix it. I just go right here and say, hey, let's multiply by the scalar -6 instead of +6. So that's why I like MATLAB. It's great. You can review your steps and see where you were going right. And now all we have to do is replace row 2 with the sum of itself and row 3, right? Because the +1 - 1 will equal 0. So how does that look? A2 equals A2. So row 2 in A equals row 2 in A plus row 3 in A. And yeah, I like that -0. So there's obviously some rounding error that has MATLAB confused. That cracks me up. You know, we can fix that if we want. We just say, hey, A2, 3. This is a good time to show the row column format here, right? So I take A2, 3 equals 0, and we can just kind of force that to actually be 0. Rather than -0, some unrounded entity there. We're almost done. And again, we can use this second row operation that I talked about. Why don't we divide through this row by 6? It won't affect the 0 here or here. And then I'll have a 1, and that'll make life easier. So let's try it. So I'm going to say that row 2 needs to be equal to row 2 divided by 6. Again, I could multiply by 1/6. There are lots of ways to do this. Pick your favorite. But what we've done is gotten a 1 in that middle entry along that diagonal. So then oh wait, so let me back up. Now we just need to add rows 1 and 2 and replace row 1 with that sum, right? I'm going to take row 1 and replace it with the sum of, the difference of row 1 and row 2. Because I'll need 1 minus 1 to equal 0. So let's try that. So I'm going to say that A1, row 1 equals row 1 minus row 2. And there you go. We are in reduced row echelon form. We have our pivots moving down into the down into the right. I have zeros below every pivot, and I have zeros above every pivot. So that's what we call reduced row echelon form. All right, let's take a look at a slightly larger matrix and see what's going on with this one. Notice we do have this column of zeros. That looks interesting. I'm going to do the same thing as before. A equals capital A. And that way we can start. I have a 1 in my pivot position, so I'm just going to start going down the rows. So I know that, row 2 is going to be row 2. And what do I need to do? I need to add minus 4 times row 1. I need a minus 4 here. So I'm going to go row 2 equals row 2 minus 4 times row 1. And I'm going to copy this because we're going to be doing this a lot. This particular row operation, because I've got my 1 there. I'm good to go. All right. Now, I need to get a 1 here, so I just want to subtract in row 3. I want row 3 to be equal to row 1, just minus row 1. And there we go. And we want row 4 to be equal to minus 3 times row 1. And now we have our zeros below row 1. I said zeros below row 1. I meant zeros below the 1 that's a pivot, the first pivot here. We got our first pivot, zeros below. Okay, so next we're going to take, and this is a fine pivot right here, the 1, and we're going to do the same thing. We're just going to start using this row 3 is equal to row 3, right? And I just need to multiply to get a positive 2 here, right? I just need to multiply, let's see, I'm going to add 2 times row 2. All right, so scroll up so you can see, and I did get the 0 where I wanted it. The 0 sitting right here. Okay, so now I need to get that negative 2 turned to a 0. So let me copy paste this, because all I'm going to do is change the row 3s here to row 4s, as you see me changing. So what do I need to do in row 4? Pretty much the same thing, right? They were both negative 2s, which you can see up here. So the same row operation ought to work on them both. And you can see that it did now that I've changed the row 3 to row 4. And now what do I need to do with row 5? Here, let me just paste this in. And so I can run back and change to row 5. Well, row 5 needs to be minus 3 times row 2 to work out. And there we go. So now we have pivots in this location, and then I don't have a way to get a pivot here, right? No way. So what I'm going to do is I'm going to come over here, and this will be my next pivot. Okay, kind of an ugly pivot, admittedly, but we are kind of stuck with it. So let's roll with it. Fortunately, we have the computer to make life a little bit easier. All right, so first thing I'm going to do to row 3 is I'm going to multiply through it by 1/2. So I can do 0.5 times this row 3. And let's get rid of those circles so we can see that this is 13. Okay. And I'm going to simplify these two down here just so that the math isn't quite so crazy. I'm going to have to multiply by, what, 32 over 13 or something. But these are both divisible by, well, by 2, I guess. So let's do that. So I can just bring this back and do it with A4. So A4, what do I want to multiply it by? A4, I want to actually, yeah, multiply through by 1/2 as well, which I can also do this way. All right. And, oh, by the way, I could make these positive as I was going. So I could multiply through by a -1/2 here and divide through by a -2 here if I wanted. So let's just run those. Right, so now I have positive numbers. That, I don't know, that might make it easier. And then in row 5, I'm going to multiply through, I'm going to divide by 5. So put a 5 here and a 5 here. So we're doing it to row 5, and I want to divide by a 5. I don't really need those parentheses. Control Enter. Boom. All right, so now we're almost done. We need to do this 13/16ths thing, which will be a little bit annoying, but we can manage it. We've got the technology. So I'm going to take row 4 is equal to row 4, right? Minus, right? So I need a 13 in the denominator. Let me see if I can get my pencil back here, right? I need a 13 in this denominator to cancel with this 13, and then I need a 16 up here so that it can subtract from this one. So it's kind of ugly how I wrote that, but you can kind of see what we're trying to do here, 13/16ths, 16/13ths. So I'm going to take minus 16/13ths. And see, the great thing is, what if I screw it up? Well, then I can just fix it because the machine is taking care of it. And look, I actually managed to get that 0 there like we were hoping. Now the matrix has switched to real numbers, right? So it's starting to give us some decimal approximations, which is fine. And now I need to get take care of this 8. Well, I'm going to do the same thing. I need a 13 in the denominator, but now I'll need an 8 in the numerator. So let me copy paste this. It's going to be helpful. But instead of applying it to row 4, I'm going to be applying it to row 5. And instead of a 16, I need an 8. And then let's check the sign, right? So I'm going to have a positive, yeah, I need a negative 8/13ths, right? So the 13 will cancel in, I'll have a 13 in the denominator to cancel with this 13. And then I'll have a negative 8 left to work with this 8 and add up to 0. So let's execute that. And there you go. Okay. And I wish I knew what that number was. Let me pause for a moment and think about that. Okay, so what I did is I just solved to figure out that I need to multiply by about 4.6. So I'm figuring that this is rounding error, and 4.6 does make some sense. So let's try to do it. I know that 4.6 times this will be equal to this. So how can I use that? I need to divide by 4.6. So let me see if I can figure this one out, and we will be done. So the row 5 is going to be equal to row 5, right? Plus, no, it needs to be minus because they're both negative at the moment. So minus row 4. And I'm going to need to get this fraction right. So I'm going to do, actually, no, I can just divide by 4.6. I was going to do 1 over 4.6, but it would be easier just to divide by 4.6. And it worked. Notice that that rounding error didn't seem to change this, right? So we were picking the right thing to multiply through by. Okay. And this is row echelon form. It's not RREF, but it is REF, right? So I have here are my pivots. I have 1, 2, 3, 4 pivots, okay? And yeah, the math did get a little bit of ugly here in the 5th column, but that's how you do row reducing. And I'm not going to do it. It wouldn't be, it's interesting because if we do this by hand, it will work out, and you'd want to track the fractions rather than switching to decimals. But it's interesting that when we evaluate RREF form, it actually just comes out to 1 and 1 and 1 and 1. So that's kind of nice. So there'd be a lot of simplification if we did these. Well, you can see here's some simplification here. It's not really clear exactly how that simplifies out, but apparently it does. So that's probably part 1 on a row reduction video. We can talk a little bit more. I'll put up a part 2 later. But again, you're going to be doing, I want you to practice in MATLAB. This is the kind of thing that you can get really good at. Now, you do have to practice by hand because doing these row operations, it is a lot of arithmetic, and you have to get good at doing it correctly. All right, so that's all I have for right now. Have a good evening and enjoy working with MATLAB.